This video is going to be for October 25th and October 26th, starting a new unit. And this unit is all going to be about trigonometric identities. So today what we're going to do is we're going to prove some of the fundamental trigonometric identities. And then we might, we're just going to breeze over other trigonometric identities, and then we might actually apply these to one type of problem. Now, I've already written the reciprocal identities, and we should be familiar with this. So, for example, sine, we know, is the reciprocal of cosecant. Cosine is the reciprocal of secant. Tangent is the reciprocal of cotangent. And so we can write those functions like this. Sine is the reciprocal of cosecant. Cosine is the reciprocal of secant. Tangent is the reciprocal of cotangent, right? So these are equivalent expressions. Sine is equal to 1 over cosecant. Cosine is equal to 1 over secant. Tangent is equal to 1 over cotangent. And similar thing here. I'm going to show y just for sine. So for example, we have 1 divided by cosecant of u. We know that sine is opposite over hypotenuse, which means this is 1 divided by cosecant is the reciprocal, so hypotenuse over opposite. But in order to divide by fractions, you have to multiply by the reciprocal. And 1 times anything is itself. So what I'm showing here is 1 over cosecant is this, but in this line of equality, we see that that's actually the same thing as sine. And we can do that for all of these 6 trig functions. If you need to pause this so you can write this down, that might be good. Just for time, I'll keep going. We also have even odd identities. So we talked about this briefly. And we said when we graphed these that sine is an odd function, meaning that if we have a negative inside our function, since it's an odd function, we can take the negative, pull that out front, and the u becomes positive. That makes this an odd function. On the other hand, cosine, if we have a negative inside our function, even functions, it just goes away. We don't need the negative anymore. It doesn't go in front, it just goes away. Tangent's an odd function. And so we can actually say as well, if you want to write this down, that might be good. If not, that's fine. Cosecant, which is the reciprocal of sine, that would also be an odd function. Secant, which is the reciprocal of cosine, is an even function. Cotangent is an odd function. Okay. So these are, again, identities that we can use in the future to simplify different expressions. We touched on what's happening with even and odd functions. We'll talk more about those in the coming months. But these are just identities that we need to have in our toolbox, in our back pocket. Now what we're going to do is prove our actual, if you're in a positive, write this down, that's fine. Please feel free to pause anytime. Now what we're going to do is we're going to use this triangle to write Pythagorean theorem in terms of sine and cosine. So let's start with sine. We already know sine is opposite over hypotenuse. Cosine means we're talking about adjacent over hypotenuse. Alright? This is going to come back and play a few minutes. Now, excuse me. Pythagorean theorem we know is a squared plus b squared equals c squared. And here we have our angle u. Let's call this our angle u. Then we know that this is like a squared, or a, or this could be a, b, or this could be b. Our two legs of the triangle are a and b. And this is our side c. Well, if we write this in terms of our angle, then this side here in relation to our angle would be our adjacent. I'm going to write a capital A for adjacent. Excuse me. This side in relation to our angle would be not h, or o, our opposite side. And this would be hypotenuse. And so what we can do here is say that this is a squared plus o squared equals h squared. But in here we say we want to use the triangle and Pythagorean to write Pythagorean's theorem in terms of sine and cosine. Well, we have this based off of our triangle here. Sine we know is opposite over hypotenuse, meaning hypotenuse is in our denominator. Cosine is adjacent over hypotenuse. Hypotenuse is in our denominator. Here we have O and A on the same side of the equation, but we don't have any H in our denominator. However, if we were to divide this by H squared, divide this side of our equation by H squared, then we would have, we can split this fraction up and say this is A squared over H squared plus O squared over H squared. That's going to equal 1. And now this looks familiar. I have A over H. That's all it's squared. Here's A over H. So this actually will become cosine squared of U. Here we have O over H. Both of them are squared. This is going to be sine squared of U equals 1. And so this is what we call a Pythagorean identity. It's one of our first trig identities that we're going to need to use to simplify expressions. All right. So this is an identity. So the point of today, I was trying to make it clear earlier, is that we're developing some identities that we're going to be able to use to simplify expressions. That's our goal. So this is one of the identities that we can use to simplify expressions. All right. I'm going to use this form to show these two. I'm going to do that relatively quickly. So we could have used this, the a squared plus o squared equals h squared, but if we have this, suppose we divide everything by cosine squared. Let's see what happens. We can do this as long as we do it to everything. We can divide everything by cosine squared. Well, cosine divided by cosine, that's just 1. Sine divided by cosine, hopefully we know that sine divided by cosine is tangent, but it's squared. Tangent squared u. And 1 over cosine, if you refer back to the top at the reciprocal identities, 1 over cosine would be secant squared u. And so what we can do is take this identity, we divide everything by cosine, we end up with this identity, which is there. Now what I would recommend is you to verify this identity here, this second one, verify that this is true by dividing each value here by sine squared. If you divide each value here by sine squared, you should end up with this, but I would encourage you to make sure that's valid and try that on your own. Here we divided by cosine squared, maybe divide by sine squared for this. All right. Again, these are identities. We're not really going to apply this in these videos. We're going to apply this on the next class. So on the next page, on the next video, we'll talk about one more identity, and then that'll be it.